The third technology is robotics. Robotics is like giving a physical form to automation. Robotics deals with the design, construction, operation, and application of robots. By robots, we mean computer systems that can control, have a sensory feedback mechanism, and can process information. Robotics deals with automated machines, that is, robots, that can take the place of humans in dangerous environments like a tough manufacturing process. Robots can resemble humans in appearance, behavior, and cognition. Uses of robotics is increasing where it is physically tough for humans to work. Places where humans have to work 24 hours in a day, it is not possible. The robots can replace the humans there. Robotics is also being used where there is a risk to human life. For example, mining or such professions where there is a lot of hazardous environment, and it makes sense to have robots rather than risk human life. Robotics is finding use in search and rescue operations. During disasters, earthquakes, building collapses, natural disasters, robots have the capacity to get through the disaster and help to save lives. Robotics is also finding use in applications which are beyond human capacity, applications that humans have never even imagined that they can do. Thus, we have reached a stage where robots will be working alongside humans. That raises a question of whether robots will take our jobs. If you look at some of the scenarios and use cases where robots are being used, for example, where it is tough for humans to work, they have to do a lot of work in a short amount of time, or where there is a human risk, or during search and rescue operations, we were clearly not up to it. Robots are going to make it easier to work. Let us watch two videos which use robots, one for search and rescue operation, and two where robots are mimicking nature to enhance human capacity and human capability.
Coyote 3. Initially built for space exploration tasks, it has shown its multi-purpose character in many different scenarios. The rover captivates with high mobility and flexibility to cope all kinds of situations. Other than space, Coyote 3 can also be deployed for search and rescue tasks on Earth. Here, the rover is equipped with an environmental sensor module. Using the camera and laser scanner, the operator gets a clear overview of the surrounding, and can safely operate the rover. With a modular system architecture, various sensor and payload modules can be attached to the rover. This allows to help the rescue teams in all kinds of situations, and increase the safety of their work. Coyote 3 provides even the possibility to operate fully autonomous, and explore extensive areas. The environment sensor package can detect gas contamination, and help to find gas leaks. This can warn the rescue forces about dangerous areas, for example with high sludge or carbonic oxide gas pollution. During its traverse, the rover automatically generates a surrounding map and highlights the detected gas concentration.
The universe tends toward chaos. But sometimes, patterns emerge, like a flock of birds in flight. But how? How does a group of animals, or cells for that matter, work together in an organized way when no one's in charge? Like termites building skyscrapers out of mud, or fish schooling to avoid predators. It's called emergent behavior, order emerging from chaos. And you don't just see it in nature. Enter the Kilobot, a robot the size of a quarter developed by engineers at Harvard. What's so interesting about kilobots is that individually, they're pretty dumb. They're designed to be simple. A single kilobot can do maybe 3 things: respond to light, measure a distance, sense the presence of other robots. But these are swarm robots. They work together. The kilobots can organize themselves into shapes, sort of like how cells form into an organ in your body. Here's how it works. The kilobots are programmed all at once, as a group, using infrared light. Each kilobot gets the same set of instructions as the next. With just a few lines of programming, the kilobots together can act out complex natural processes. For example, how do a group of identical cells in an embryo develop into different parts of the body? In nature, this is a fairly mysterious process, but with kilobots, you can recreate it. See here how the kilobots start off blue and then start randomly blinking either red or green? Their instructions are really simple. Respond to your neighbors, match their color. But just with that simple programming, they begin to differentiate themselves into red and green sections of the group, a lot like cells differentiating themselves in an embryo. Or here they're dispersing, based on the way gas bubbles spread out to fill a volume. Here, a swarm of fireflies that start off blinking randomly and eventually begin to flash in unison. These kilobots are mimicking the way bacteria find food. That light represents food. See how they're rotating and inching forward, slowly homing in? Programmers figured out how to make the kilobots do this by watching bacteria search for food in a petri dish. But here's the thing. The researchers were then able to make a better program. They revised the software. They came up with a new, more efficient way of solving the problem. And that opens up a really tantalizing possibility, because our cells can be programmed too. With the right tools, you can actually go in and alter a cell's genetic code. It's software. With the right code, maybe you could, for example, teach white blood cells to track down and kill bacteria or cancer cells more efficiently. One day, instead of us teaching kilobots to mimic nature, they might teach us better ways of doing things, and then take over the world and destroy us all. Just kidding.